Hey, g'day, it's Presso. Thanks for stopping by. Now I'm starting on a new project today. It's going to be a multi-part series. There's a lot of machining involved, some casting, some finishing work, but let's have a close look at the bench and talk about what it is. Oh, there it is, or at least that's a 3D render of what I'm planning to build. Now, you'd probably look at that and recognize this thing as a float lock vise, and there were a series of excellent videos done by Mr. Pete and Blondie Hacks some time ago where they made a similar style of vise to this one. Now, these things are still sold in the United States by a company called Penn tools, and the brand name for these vises is Wahlstrom. I think there's about 3 different variants, and they're an excellent tool, but they cost about $359 US, and if I was to try and get one here in Australia, by the time I paid shipping it'd cost me $500. And I don't think I've ever seen one of these as a used item being sold here in Australia. So I was all out of options and I decided I'd just build my own. Well, there's a 3D printed mock-up. Now my workflow for this is I will usually model all of these parts in 3D CAD. Autodesk Inventor is my program of choice, and then I will do a set of 2D drawings with all of the details and dimensions, and then if I can I'll 3D print as many parts as possible. Now in this case the 2 jaws are 3D printed. These 2 steel parts are not finished and they're not the correct size. These were just representations of the parts to check the operation. And what was worrying me was the mechanism for moving this fixed jaw over short distances. It's only 7 or 8 millimeters, I think, and then the moving jaw can close 25 millimeters or nearly an inch, and that means that you can always grip a part between these jaws. And the fixed jaw is sort of like a quick action. You can move it along the bar very quickly and lock it. So in operation what you tend to do is you put your part between the jaws like that. Now around here I've just got a hex-headed nut now, but this will be replaced later on with a small handle, and you can close that jaw up there and it does lock, and you can see that it's locked there quite solid. But this little pin here is the key to the movement that allows you to quickly reposition this fixed jaw, and I wasn't sure whether it was going to work. That's why I've made this mock-up. But I think it's going to be okay. I have not been able to get that pin to move by tightening up on the nut, but of course being only plastic I can't over tighten it, but I think that that's solid enough now. So let's take that out of there and let's have a closer look at this quick release mechanism. Well, there's a close-up of how the system works, and this is a piece of 20mm round bar stock, roughly 3/4 of an inch. There's a 6mm or 1/4 inch keyway in the top, and then there are a set of holes inclined at 45 degrees and on 9mm centers along the axis of the bar stock. What that means is that pin, which also locates the fixed jaw, can move over those discrete 9mm steps, and this other jaw here can close up to an inch or 25mm. Now, this is not exactly the same as the way the original Wahlstrom vise was made. And I saw a video by Tom Lipton, or Ox Tools, and he had one of the original Wahlstrom vises. He demonstrated how it was used and the mechanism and so on. And then he said he was going to sell it or give it to Chuck Bomarito over at Outside Screwball. Now, Chuck ended up with the vise and he did some posts on Instagram and sort of showed some close-ups of it. And I couldn't quite see how I could manufacture the same mechanism, which is like a set of steps, or like a sawtooth if you like, and this was the best I could come up with. So a lot of people will probably tell me that you did it wrong. I've only got a little brain. It sort of seemed like the right option for me. If it turns out that this method of dropping the pin into those holes is a bit of a pain, I may have to rethink that. I did actually come up with another way of doing it, but it means making a very, very deep keyway and then profiling the steps, and then you have to hold it in place with rivets or welding or something. But I think this will work, so that's what I'll go with. Let me show you some drawings that I found that helped me design the rest of the mechanism. So if you Google Wahlstrom or float lock vise, you'll probably find this document. So this was a PDF that I found, and it's about 6 pages, 8 pages, and it shows the various models that Wahlstrom make in this style of vise. Now this one here is called a bandsaw vise, double-ended, and the 2 jaws move symmetrically, allowing you to grip a part on a bandsaw, but we're not doing that one. We're doing this one here. Now this is called the Model 18-9. Now I think that means that it's 18 inches long in the bar. There is a longer one, exactly the same mechanism though. And then there is another one that has a screw running down the center of the bar, but in that one you have to crank the handle to open the jaw. So you know, lots of cranking to get it to open up the full weight. Now these photographs show you the various different ways you can use the vise and some tips and tricks for getting the most out of it. But this was the drawing that helped me the most in order to get this thing designed. So I reverse engineered the mechanism of this drawing here. So it shows an exploded view, and it was this section here which showed how the plunger and the locking mechanism worked that was most interesting. Unfortunately, it doesn't detail how that ratchet mechanism works, the actual steps in the bar. But like I said, I've just sort of done it the best I can. But pretty much everything else is going to be the same as what you see there. Now I've got some patterns here. These are 3D printed patterns and they're a split pattern. These are going to be cast in aluminium. Now I'm guessing the originals were cast iron with steel jaw faces. I will put steel jaw faces on these. And I've got a third pattern here. This is the bracket that goes on the side of the drill press table. And that replaces a part which is here. It's like a little clamp that fits on a rectangular or square table, but on mine I'll be using this. Now first thing I have to do is make some cores so that when we cast these it will have, you know, a hole through the casting, so we just need to clean the hole up. So let's go and make the cores and then we'll do the castings. I always leave a little bit of that sand and epoxy mix in the mixing container, and then when that's sort of hardened up, you know, you can dismantle the cores. So we'll try and get these out now. I should just be able to take the tape off, and we'll see if we can just leave it as open. Alright, plan B. I think it's loose enough, it's just I can't open up the PVC tube far enough. I'm just trying to put a cut in the back of that tube there. There we go. Alright, so there's our core. I'll just clean up that little flash line there with some sandpaper. Can sand these really easily, and they're really rugged and solid, so there's very little chance of breaking these when you're setting up the mould. So there's our finished cores, and these things are quite rugged and quite solid and easy to work with, and yet they come out of the finished casting quite easily. So after you finish the casting, just poke it with a bit of wire, it'll disintegrate and come out. Now on our pattern, on both sides we've got a thing called a core print. These are traditionally painted black, so you know that they're meant for a core. But what happens is when you ram up the mould and then take the patterns out, there will be a half round shelf on both sides of this part of the pattern, and our core just drops into that half round shelf. And then when you reassemble the mould and pour the metal will flow around the core, leaving that void through the casting. So for a casting this size and a hole this size, you probably don't need a core, you can just drill that out. It does save a little bit of metal, and it means you don't have to waste quite as much material. But let's go ahead now, we'll get the mould made up, and then we'll see if we can get these castings made. So I think what I'll do here is I'll put both patterns sort of adjacent to each other. There'll be a common sprue in the center, and then we'll put gates into both parts. And what I think I'll do is to put a riser on top, or a feeder if you like to call it that. So when we do the cope, there'll be a feeder on top of the pattern there, same there, and that way we can replenish that metal that shrinks. So I'll go ahead and get this one rammed up. I'm going to use K-Bond sand. It's an oil-bound sand. It's a little bit more forgiving to work with, but it's harder to make. So I think we're going to put our sprue here. I think it's worth just firming that sand around these bits of tube here so that you don't dislodge them sideways. If you start ramming too soon, all the sand around it's soft and it'll just shift one way or the other. And you've got to sort of keep an eye on it, make sure it's not migrating somewhere where you don't want it to go. Just put that back while I cut the pouring basin, just so it doesn't sort of break sand back into that tapered sprue there. Sort of makes it easy when the pattern falls out. When you go to wrap the pattern, you want to look at the edge and you see a gap showing up all the way around, and whatever tool you're using to do the wrapping with will just simply knock the pattern side to side. And I can see a gap opening up there now, but this is a very simple pattern to get out anyway. But just for the fun of it, I'm going to use my pattern extraction tool. Now this gadget here is a tool that I made some time ago, and my problem is I've got shaky hands, and trying to get a pattern out of a mould means that you've got to lift it vertically. If you let it sort of move from side to side, you can brush the edge of the cavity as the pattern comes out. That can dislodge sand or ruin the shape of the cavity. So with this thing here, what you can do is you can rotate the main shaft there, which has a screw thread on the end of it. So it goes round and round like that. And you can move the arm over your mould. And you've got a small range of movement down this end here. There's a slotted link in the end of that arm there. And you drop the screw into your pattern like that. So then we lock everything up. Just make sure that it's still aligned. When you loosen this knob here, that whole square shaft can rotate, so we can drive the screw into the pattern, then lock it, and then it's just a matter of lifting straight up on that square shaft there, and it will lift the pattern with it. All right, here we go, deep breath. And just make sure you don't drop the pattern or that screw back into the mould. Right, we'll do the other one, even though that's really simple, this one here. The same deal, just lift it straight up. Alright, that part of the mould, it just needs to have the gates cut. I'll give that another blowout with air later on. I lost a bit along this edge here, but that'll be okay. That'll grind off easily enough. So I'll put that one aside. Pretty sure this one will come out. No, better not. Don't tempt fate, Mark. Okay, again, deep breath. So with this one cleaned out now, we can put the core into the core print, and this is a really easy one to insert. And the core print's slightly longer than the core itself, so there'll be a space at both ends of about 2 to 3 millimeters, and that will allow any gases that are forming in the core to go somewhere. There is a vent right down through the center of that core there. I just poked a wire through when I was making it. And that does help to allow any expanding gases to escape to this gap at either end. So with this one, we just got to very carefully drop that in. And then we can put the cope on top, and we'll go and fire up the furnace and we'll do these. Well, that one looks pretty good. I'll clean that sand off, I'll have a closer look. And a lot of people don't like this K-bond sand because of the smoke. I don't mind it. That looks pretty good, but interestingly there's a little cap of aluminium on top of the exposed end of that core there. And I'm guessing that flowed through that vent hole. But that should just come off. Maybe not. There it is. So now you can see the core, you can see the hole through the center of the core, and that core should just break up and come out. Now I won't do it into the muller because I don't want to mix that up with my K-bond sand, so I'll do that outside, but I'll show you what it looks like shortly. Let's go and get the other one out. Alright, that looks like a winner too. So I'll get this one cleaned up and then we'll have a go at removing the cores. And yeah, satisfaction guaranteed. I've just cut the gates off this one here, but I've left this riser intact. But there's what's left to the core, and it just breaks up, comes out as easy as that. So if you ever wondered about epoxy and sand cores, they do behave very, very similar to the regular sodium silicate cores. It's absolutely no trouble to get them out, but they stand up to the melted metal temperature quite well. So that was the casting that was in its own box on its own. This was the one that had two, I think. So there's the other one there. So again, just screwdriver, just wiggle it around and it just falls out. Now I did put this under the tap to cool it down so it's absorbed a bit of water. So wait till I go and clean this out with compressed air and I'll show you inside. As you can see there, the walls of that cored hole are really clean. It's perfectly smooth, almost doesn't need machining. But very happy with the way that went. Let's have a look at all the castings side by side and we'll look at the project and see how it's shaping up. So here's our two finished castings. There's our mock-up, and this mock-up here is printed the correct size after machining. So it's 36 millimeters wide and our rough casting is 39.5 roughly. Now that was deliberate. When I made the patterns I did make them oversized to allow for that machining process, and I guess the next thing to do is get these cut off and then we can think about the order of operations for the milling process. But part of the complication with this is that you've got to attach a steel jaw to this part, and it has to have the bore lined up perfectly, and then of course you want the outer edges of that steel jaw to match up with the aluminium jaw, and you want the grooves. There are V grooves in the jaws. They have to be centered on the parts and they have to align exactly with the upper jaw. But successful day in the home foundry, so yeah, I'm a happy boy. Well, I think I'm going to finish up here now. In the next episode on this clamp build, I'm going to start machining the aluminium castings. I've got some hot rolled 10mm thick steel stock. These will be the hard face jaw which gets screwed onto the aluminium casting. Now I've got some mounting hardware for doing that. Bought that today. I've got some 3mm roll pins, and these are essential for the assembly at a later stage. And yeah, that's what we're doing in the next video on the clamp. Now, there is going to be an interim video. It'll just be a short one. It's an announcement about the channel and the whole monetization thing for the videos and a charity that I want to support. So we'll discuss that for the next clip. And if you're worried about the audio quality on this video and maybe the one before, it's because I splashed out and I bought a Bluetooth wireless lavalier microphone. This brand here is a Boya, B-O-Y-A, and I thought this was the answer to all my problems for audio, and it turns out it's just created new problems. So it seems like there's some sort of automatic gain control with this device, so during the quiet periods of the clip it boosts the volume and then it has trouble leveling that back out later. So it means a lot of manual editing in the video software to try and fix that. So jury's still out on whether that's a good buy or not. I may not use it again, but a bit of an experiment, and if it's failed, I'm sorry. Alright, so that's all for now, and I'll catch up with you for the next video, like I said, short one, and then we'll get back onto the clamp build. So for now, it's Presso, signing out, and I'll see you on the next one. Cheers.